Hello friends, welcome to our channel. Let's look at problem 2900. So in this video, we're going to explain how to use index partition method to do this problem and also do some extensions. Our plan will be the following. First, we're going to introduce a quick solution, and then we introduce the solution based on index partition, right? This is the recommended way based on the attention. So let me first do version v1. So here we want to find the longest alternating subsequence. So actually we can always start from index 0. So first I'm going to get the length of this say words. Notice that length of the words and the group are the same. So we can always start from 0. Why? So actually you can think of like this. So if the first two elements in groups are the same, then starting from any one of them will be the same. So we can start from 0, right? So if the first element and the second element are different, then again we should start from 0 because this will extend the length. So with that said, we understand why we start from index 0. So now let's iterate. So for I in range 1m, right? If groups so g negative 1 does not equal to groups current element, so I'm going to do g append current index, and then what we want to return actually is nothing but words I for I in g, because g contains indices. Let me first submit that to make sure it works. Yep. So with that said, let's do the second one, explain the index partition way. Let me copy this function signature and put it here. I'll change this one to be version v1. So now let me make some annotation. So this is the quick way. But here the second way will be index partition way. Index partition. So this way of solving the problem gives us more information. So here, if you look at see this example, so you know I can group the consecutive ones and zeros. So for example, this one. So the one corresponding to index 0, and then begin now the consecutive zeros corresponding to index 1. So we have this. And then the last two ones are one group. We have 2, 3. So this will be the partition, right? So then you can, because consecutive there are the adjacent list corresponding to different consecutive values. So you can choose from one element from each of the list. So you can choose 2, or you can choose 0, 1, 3. But the length, the longest length is the same. The length is 3 here, right? For this example. So then we just need to find the corresponding words to construct the output. So this will be our full idea. So now let me do this one. So here we store indices, right? So this is a list of lists. Each inner list or element contains consecutive indices corresponding to either 0 or 1. So how do we get this partition? It's rather straightforward. So for I value in enumerate, so groups. So if not P, right, I haven't put a list yet, or P negative 1 corresponds to different values, groups. And then in this case we need to start a new one, so with p append, so this index I. Otherwise, so because the last list corresponds to the same value, so we're going to do p negative 1 append I, right? So before you push forward or do the return, you can print out this p for some information. For example, indices must be integers, also let's not list. So here, let's see, if not p or groups, p -1. So here -1. So let's see. This corresponds to 0, 1, 2, 3, as we explained, right? So now everything is right. So now let me comment this out and then do the return. So for the return, I just need to return so words, so element. So we can choose any, so 0 or -1 as you like. So for E in P partition, right? So now let me submit that. Yeah, it passes all the cases. I guess for this way of doing the problem, actually we can address some extensions. For example, can you compute how many longest alternating subsequences, the longest one? So for this example, you just have 1 times 1 times 2. So those 1, 1, and 2 are the lengths of the corresponding partitions. So can you construct all of them? So you can write it in the, using some loop or using some products or using some backtracking, right? So this will be the effect of index partition. So here I want to make another comment. Actually, this is the one problem. You can use index partition. Actually, there are a lot of different problems you can use index partition, either in terms of list or in terms of dictionary, right? Each dictionary key corresponds to a list, right? So with that said, I guess that's it for the current video. Thank you for watching.